Welcome to this video. And the previous videos, we had a look at Firebase in general, and then at how to structure our data. Now we got our structured data, we got Firebase set up, but now we want to ensure that, we write to this data correctly.
Yep.
And what can you tell us there about the rules, basically, which is a super important feature?
Yeah, so the Firebase security rules are basically how you restrict who can write to your database. Because when you're dealing with a database that gets written to from client devices, the likelihood someone could try to add malicious data, or you are just not filtering out all the bad data they might write, is very high.
Yeah.
So we want to use these security rules, which will be this kind of JavaScript-y type language to say, here's who can write where, here's what they can write. That way you know that the schema and the data that you're having in your database will be great and render in your app perfectly, and everyone will do what's expected, and you won't be leaking user data to anyone who shouldn't have it.
Yeah.
So like I said, this is a JavaScript-like language that will kind of mimic the structure of your database to let you lock it down.
Before we dive into that, there's one super important thing, because you could think, well, why do I need this? I could check this in my client-side code, right? I could basically do validation there. I could even check the user ID. There's one big issue with that your client-side code is, especially if it's a web application with JavaScript, always exposed. So even if you minify it and make it really unreadable, there always is a chance of getting there and basically disabling your validation, for example. And that's why we need to do that all the time, every time on the server. You can add validation on the client to improve the user experience, but never just to rely on that.
Exactly. Yeah, you want to use your client-side validation to say, oh, that isn't a valid email address, or you clearly didn't need that character in there, whatever. But in terms of saying you cannot write that, I'm not allowing you to write that, that's what you'll do with security rules.
Yeah, so why don't we dive a little bit into that with an example?
Yeah. So let's go into our data for a second and look at our structure. And the simplest possible use case here is like a user profile.
Yeah.
So if I have a profile, we were talking before about using this user ID here to look up who created this message and using that to pull in a photo URL or anything like that. So let's build up that structure in here so we can see it, and then we'll write the rules to lock it down so only I can edit my profile and you can edit yours. So we have this unique ID that came from our app. So in this case, I'm going to type it in. In reality, you could make this structure when your user signs in, do it on the client, do it with the cloud function, whatever you want. But here, I'll just type it in for fun. So we'll go up here, we'll add a new top-level node called users. Then under that, we'll use this user ID as a key. So I'll paste that in there, that is copied from there. Then we'll have a name, and we'll call this user Abraham Haskins. And a photo URL, I don't have one, so I won't actually put one in there. But we can add that, and we'll get name Abraham Haskins. So that's our user profile. But right now, anyone could come edit this, right? If you knew my crazy ID, which you would, if you came in and looked at this message, your client read the message, you'd be able to grab that UID. So we need to lock this down. So we'll go over to rules. By default, you have two rules in your Firebase database. You have your read rule, which obviously controls your ability to read data, and your write rule, which controls your ability to write it. And the defaults are auth doesn't equal null for both. This is already a little strange because we don't know what this auth object is, but it's pretty straightforward. The auth object is your user. So when you sign in with any type of authentication, Firebase authentication, and try to write to the real-time database, the user ID, the information about what type of provider, if it's GitHub or Google or whatever, all gets passed through to these security rules as this auth object. So this is auth state. You can think of it as your user. So what we're saying here is that you can read all the data in my database if auth doesn't equal null. In other words, if auth is anything, or if you're signed in. If you're not signed in, auth is just going to be null. It's just going to be empty, so you can't read or write anything. If we change this to, for example, true, that would mean anyone can read our data. And that has some interesting side effects. You can go and, for example, pull your entire database down as JSON right now. So you generally don't want to do that, but you could if you really wanted to, or if you were... it's not my native keyboard.
It's not a native keyboard,
So you could do that. But if we want to do control that's not on the database level, like this is allowing reading of everything, we need to step in a little bit. But I think one cool thing to illustrate is we'll publish this, we'll go over to this rule, and we'll copy this link, and see, open up a new tab, paste this in, and if we type in .json on the end of that URL, it'll give us a permission denied because our rules are saying you can't read that, you're not authenticated. So if we say read true, publish that, hop back over here, we'll get our entire database back. Now, as we step in, we're going to allow reads at different depths, at different locations, but we're not going to allow reads at the like this, where we're just saying pull my entire database ever. There's no reason any user would need to do that. So let's make a profile. So we'll leave that as auth doesn't equal, no, actually we'll completely remove that rule because we don't want anyone to ever read at the root of our database. And then we'll mimic the structure of our quote. There you go. We'll mimic the structure of our database. So we'll have that, and then, man, there's a lot of crazy keys on here.
Which one? You're
the square, the mustache bracket.
That's Alt 8.
Alt 8. Oh, okay, yeah. All right, so we'll have users, and then under users, we'll have $UID, which I'll explain in a second. Then under that, we'll have, I'm just gonna copy and paste the whole time. Alt
9.
There you go. Cool. Yeah. And under here we'll have our read rule, which will look like, man, this is tough.
Some extra challenges in there.
Yeah, right. It's like programming is too easy in general. We definitely got to add in some extra difficulty. Doesn't equal no. Cool. So what we've just done is made this hierarchy, and we need to come there.
Yeah.
We publish this. If we go back over here. If we go back over here, refresh this, it's going to say permission denied because we removed that read rule at the beginning or for the root of the database. But now if you read users / a specific user ID, so this is a wildcard. So we're saying users is going to line up with users here, this top level node. Then it's the wildcard is going to match this crazy ID.
Any of them. So basically
any ID, And then down here, we're just saying now you can read it. So this wildcard here isn't going to be used right away, but we can use it in our rules. So like I said, this auth object is actually our user. It has all the properties about who is trying to make this request. So if we said auth.uid equals $UID, this rule is now going to say the only person who can read this is the person whose UID that's been secured and verified by Firebase authentication matches this UID. So we've now locked this down. So if I go in here, even if I like stepped into, deep down, oops, that's the wrong one, deep down into this location, and we can just type this in the URL, so it's /users /7, thank you. There you go. It's going to give us a permission denied error. But it's because we're unauthenticated, which is exactly what we'd expect. But if we went in through our app and tried to read that, it'd be all good. But this isn't quite the case we want, right? Our user profile should be readable by everyone, but it shouldn't be writable by everyone. So we'll change this to a write rule. And then we'll change the .read to, we can actually just say true.
By default, we already saw it basically, but by default, if we don't specify read, it's all assumed false. So everything is locked down by default.
Exactly. So now anyone can read that profile, but only you can write to it. And we can check that one more time. I can actually step all the way down into this, get this URL, command CTP, paste that in, add in .json, and it will let us read it. Now you'll notice this object that gets returned has a property called name and it's Abe Haskins, which looks just like the data we have under that object. But we can actually step in a level deeper if we wanted to. So we can say /name and pull out just the name, and then it's just a string. So by giving someone read access at the user level, we give them read access, complete read access to everything under that. And that goes back to what we were talking about, where you're loading data, you're always loading all of it under that location. If you're giving someone read access to something, you're giving them read access to everything under that location. But at this point, we've locked this down. That user profile is not getting changed unless you are the person who is signed in with that UID, and that's not happening unless you sign in with that credential. And you don't have to do anything special on your client to enforce this. As long as you've signed in, you're good to go.
Okay, cool. Yeah. And you just mentioned it will go down. So if we have read access there, we can also read the nodes basically.
Yep.
But does it also propagate up? So if we have some read or write access at level user ID, can we also write to users then?
Yeah. So you can write anywhere below. So if I have write access to $user ID, I can write to anything below this. So I can write to the name, I can write to the account as a whole. But if I have write access only to my account and I tried to write at users, even if the only change to the data was in my UID, it would be disallowed. So you have to write to a location where you have either an explicit read rule or one of the parents has a read or write rule for what you're trying to write.
Okay. And we do have read and write here.
Yep.
I believe there also is a third option, like validate.
Yes.
Well, what's the role of that? How does it compare to write?
Yep. So read, obviously reading. Writing is saying, can I write this or not? Validating is for checking that what you're writing is okay. So whereas writing is, I am like allowed, I have the right UID. Validated for checking, is this a number? Is this a string? Is it within the length? Does it match this regex? All of those things, which really aren't part of the permission model, but part of the schema, that gets enforced in a .validate rule. So we could add one for our user profile, and we could say under this. So we'll have a child that is name, and we'll have...
Well, we actually might add it to messages maybe, because we can fire this from our app and then we can see
that's good. Yeah,
we could force that it has to be like 6 characters long or something like that.
Yeah, so we can do a bunch of different stuff like that. In this case, we're using our UID here. So what would you want to enforce on the message?
Maybe we could say that the content should be at least 6 characters long or something like that.
All right, so let's do that. We can go and make another structure. So we have users, but because messages are separate, we need to make another structure in here. Oh, this is a great catch, actually. So this rule is still here.
Yeah.
Auth doesn't equal null. Because that rule is still here, this rule would actually be overwritten. Because this is saying at the root, anyone can write. So if we didn't delete that, that would allow somebody to write at any location. So we really need to make sure we
saw that.
Yep, absolutely. All right, so we'll do that messages node next. So we'll say messages. And under that, we'll do that same wildcard because our messages each have those crazy IDs. So we just need a wildcard match to match odds instead. Just need a wildcard.
More practicing with the keyboard then.
Yeah, I'll get good. By the end of this, I'm going to be like a pro.
Should be messages though.
Yep, you're correct. Messages. $, we'll call this message ID. This can be anything you want.
Yep.
Whatever makes sense to you is what that should be called. Under there. So now we're at the messages level. So in this case, who should be able to write a message?
I think everyone who's authenticated
should
be
able
to write.
All right, so we'll write that rule in real quick. So we'll say that write. Anyone who has auth doesn't equal null. Good. All right. Who should be able to read messages?
Let's say everyone should be able to read it.
All right. So here's an interesting point. Like I was saying before, if I was trying to write at users, and even if I was only writing to UID, I wouldn't be allowed with this rule.
Yeah.
That same thing happens here with reading. If I wanted to read every message, even if the read rule on the message ID allowed it, it wouldn't allow me to read messages.
Yeah, because it's locked down by default.
Yep. So we have to go a level higher to be able to get the list of every message for this read rule. So we'll say read, and on this one we'll say auth doesn't equal null. Is that what we're looking for?
Yep.
All right. So now we're saying anyone can read messages as a list. They can get every message ever, but these rules, the message ID we're stepping into because we're going to do something a little different. All right. So Message ID. Now, on here we wanted to validate the content links, right?
Yeah, but before we do that, we can actually jump into the app and show how it's working thus far.
Absolutely.
So we got read and write set up, so we can simply open the application, still running. And we need to sign in there anyway, so let's quickly do that. Created a user before. Let's hit sign in. And now we can...
Well, we're reading already, so that's a great sign.
Yeah, right, that worked. Then let's open up the console to see if we're getting any errors.
You're the one who's supposed to be good with it.
Yeah, so this is very, very difficult all. So let's now try it again and let's send a new message here maybe. Let's hit send and it worked. So that's working. And we can even maybe, before we continue writing it, screw this up and go back to our rules.
Yeah, definitely.
And if we set off simply to false, then we shouldn't be able to do that. So we can still read everything, so we still see our messages here, but if I now simply send the same message again, we saw it was added there for a brief second, but that was just due to the front-end app where I did some optimistic updating.
Well, that's exactly, and that's something to keep in mind. It's the optimistic updating. So Firebase says, oh, I think this write succeeded until it realized it didn't. That didn't make it to the server. That was never in the database. No one ever saw that. But your client side app said, oh, I thought that was okay, and then it rolled it back.
Yeah. So, and we see the error message here too. We're not handling it here. That's why it's just printed there. But we could catch that and output it there, of course, in a nicer way. But here we get a permission denied error. So that's exactly what we wanted to see because we got no permissions. So
Yep, definitely.
Does this work?
Yes, it does.
Great. So now we're back to the original state. And now we can try to validate this to make sure that we only can write messages which have at least 6 characters, for example.
Yeah. So we should be able to just go ahead in here, write a new .validate rule. And of course, this is all documented on the site if you need help following along with this.
Yeah, and link can be found in the video description.
Yep, and we have a reference for all these variables, everything like that. So when you write data to Firebase, it's going to come into the security rules in 2 different forms. One is data. Data is the data at the location you're writing when the write happens. So what that means is if I have a user profile and I write to it, data is the data that's currently there, not the data coming in with the write. So we have data, and then we also have new data.
And both are reserved words, so we have to take them. We can pick anything with the $sign in front of it, basically, but these are variables built into the system.
Yes, exactly. So new data will be the data that is coming in with the write, so what they're trying to write. So in this case, we're going to go and we care about the content field, is what it's called. So we'll say content, and this validate rule is going to happen on the content. All right. Then we'll say new data dot val. If I can type that, and say dot length.
Also, just a quick side note, val makes sense because that's also how we can retrieve data when we get it in the client.
Exactly. And we say greater than 6. So just like a string in JavaScript, we can check it. And we hit publish. That's been published. And one of the really cool things is if I had a mistake, I didn't make any mistake here, but if length wasn't a field or val wasn't right, it would tell me right now. This isn't something that would like bubble up in your application. If you write your rules, although the logic might not be right, the variable names and stuff will be right if you try to publish.
Okay.
So we can hop over here now, and what this should do is enforce the length of the content field. So we'll try this with a new message that's nice and long. That should send just fine.
Works.
But if we try a shorter message that's only 3 characters, we hit send. Flashes, and we get failed, permission denied. It looks the same way on the client for security reasons. We don't want to say on the client, like, oh, you didn't fit this criteria, because then people would like work around it and then try to get through your security. So we just say it's permission denied. You can't write that. That message is too short. But you could definitely catch that. And if you're doing client-side validation, you do the same validation and say, oh, it's too short. I can bubble up a good message.
And that's exactly the thing we talked about earlier. So here, obviously, this message alone doesn't allow us to create a good user experience because we couldn't tell. Is it because we're not allowed?
Yeah,
or because
it's not like the off message, right? That was really nice.
So that's why it's important to do the client-side authentication, validation, where we would now check this before we send it. And if someone disables that, well, then we don't need to show a good error message anyways.
And generally, if you hit permission denied errors, those are malicious users.
Yeah.
These aren't the type of thing we expect a normal user in the course of using your app to hit.
Yeah.
So if they are hitting those, you don't have to really be that nice to them.
Yeah,
They're probably not being nice to you.
Because true, you should manage the nice stuff in your client app anyways.
Yeah, exactly. Yeah, and validation rules are a little different there, but in general, you shouldn't be hitting many permission deniers.
Yeah.
Cool. So the very last thing in terms of our message that I want to implement is I want to make sure, right now we're constricting who can write to their profile. And we're relying on the data here inside of our messages, this user ID field, to be the right user ID.
Yeah.
But we're not enforcing that.
Yeah.
So anyone could write anyone's user ID, and it would end up looking in the application like it was sent by you or sent by me, when that's not who's sending it.
Yeah.
So let's make sure that this user ID field, when it's being written, is the UID of the actual user. So we can do that same thing here, where we have, we'll step into a field. This one's called user ID, just like in our actual data. We'll say, pull up that, and this will be another validation rule. This could be a write rule, but remember that we're giving them write permission at a higher level. So if we had a write rule here, it wouldn't be enforced because we give them permission up here. So it has to be a validate rule, which allows them to write either at this location or this location and have it be validated. All right, and then we'll just say new data.val, and that's going to equal auth.uid. Hit publish. That's all you need. And now no one can write a user ID. That's not theirs. And I don't believe we have a super simple way to show this in the app, but we could try to hack it and write data, and it would definitely not let us write it. So we know that not only is this profile locked down to the right user, but every message that comes in has the real UID of who wrote it.
Yeah, that makes a lot of sense. And we can actually, I guess, now we can show it if we add a new user and edit the code here. Could simply hard code the UID in there.
UID, yeah, that'd be great.
So that would be something. Yeah, we can do it with this user even. We can simply just add any random string here. It doesn't really matter.
So in this case, it's random, but it could be another user ID, an admin's ID, anything like that a malicious user might get their hands on.
Exactly. And if we now save this and quickly log in again. That's the sign up. So we saw that Firebase also makes sure that we can't have multiple
is that
email
friendly error message bubbling up right from the SDK?
Yeah. And now we can see that if we open up the console and we do write some message here.
There you go.
Again, permission denied because we, try to override this user ID, which doesn't work.
Yep.
And you mentioned something else very important, that in the rules, very important question is, what's the exact difference between write and validate? Because obviously you can use the new data variables and so on, also in the write rules.
You absolutely can.
So that's not the difference.
The technical difference is in how they cascade, which is a complicated way of saying this write rule, even if I put another write rule in content instead of that validate rule, this rule would be overwritten every time by the parent one. It would be ran if they were trying to write specifically to message ID content, but otherwise this parent location is going to be the write rule that gets written. Validation rules get applied at any location. So if I'm writing even to messages, and I'm writing a really deep object that has messages and message ID, whatever, those validation rules have to pass. So the validation rules are, like I said, for enforcing schema, so making sure that this data, if it gets in here, regardless of what allowed them to do the write, that it matches the format you want it to match. That's what you do in a validation rule.
That's really important to know, because otherwise it can be confusing that you have two ways of controlling writing.
Exactly.
But actually, one generally you can say write is for everything which is really related to permissions, to authentication, or not to authentication, but to permissions, who is able to write something or what can you write. And validation is really just for, validation.
Write is for who, validate is for what.
Yeah, perfect. And obviously, if you want to dive deeper into that and learn about all the built-in variables, because here we saw new data and Abe mentioned data, and we see auth. But there are more than that, and you can find them all in the Firebase reference. You can also find great articles here. So if you scroll down to security and rules there, of course, the same.
We have a whole section about it.
Yeah, there's a lot of information about it with a lot of examples, because super important to get it right, obviously, because always important, you can't control it from your front end. You need to do that here. And you have a very expressive language. You need to get the grasp of it, I guess, because it is not super obvious how it works, maybe at first look, but it's super easy to get into it in the end.
Yeah, once you start seeing that it's just mimicking the structure of your data and putting like little JavaScript snippets in there, it's pretty straightforward. And realistically, your rules don't have to get that complex. If you do good client-side validation, as long as you're enforcing who is writing where, you'll be in a pretty good spot.
Yeah, and that's important too, because here in the security section, there are really complicated rules too, which makes sense. But oftentimes you don't need to go that.
Yeah, a lot of times you don't have to.
Yeah.
And it's the type of thing where if you really care about your schema, or you think about malicious users, like you could, or if you really care about rendering right and you don't want a malicious user to break your UI, you can also be smart on the UI side. So you can say, all right, you can write some ugly data to my database. I'm not going to write every validate rule to be completely perfect, but when I get it back client side, I'm just going to check it.
Yeah.
I'm going to be like, does this make sense for what I'm trying to do? And if it doesn't, you throw it out and either delete the record from Firebase or send you an alert and say, hey, someone did this. You have a bunch of options, but you don't need to dive super deep into security rules to get a ton out of them, but you should definitely invest enough to lock things down and understand what users are writing where.
Yeah. So that was great, but just one last point now that I see it, we also have has children and child here. I think these are maybe things you don't need that often, as we just said, but it is important to know about them, because right now we always considered rules where we only have a look at the node we were writing or reading. We can also reach out to the parent node, for example, if the condition is related to that, right?
Yeah, for example, on content, you could check that it matched another field, or, like content, or, a timestamp matches another created ad, or things like that, where you rely on each other's data. You can definitely do that. And on the parent level, you can also say, this parent is only valid if it has these children, so it needs a content field, it needs a user ID field. You can basically do the same as these validation rules on the parent and say, okay, this parent's child has to be a string, it has to be this. It's a little cleaner to do it this way, but you can definitely do that where you're like reaching out, and you can in fact control the entire database, or not control it, but access it from any rule. So you could say, okay, you can write here if you're the right user or if they're an admin. And you could have a table of admin users that just has UIDs flagged to true. And when you go go in your rule, you can look up in that little list and say, oh, that's the right UID. They're an admin, let them write. Yeah. So you get access to everything. It's not just the field that's being written to.
That's super important to know too. And with it, I guess, got a lot of tools to work with. And I want to say a big thank you to you for walking us through that and giving us a little more, introduction from someone who really works on the product.
Yes, absolutely. Thanks for stopping by. I hope everyone got something out of this. I hope my genuine excitement for the product shows through, because I absolutely love building stuff on Firebase.
It sure does. And I will also do some other videos about that where we dive into how we use the SDK and so on. So that's all part of this series, but really awesome to
Awesome.
discuss that. Yeah, thank you.
Absolutely.